So for question A of 11, it's x plus h quantity cubed. You just multiply it out and end up with this. And then for B, you implement this with the definition of the derivative. And what you do is you plug in x plus h to x cubed minus 4x plus 1, and you will end up with this part. And then the definition of a derivative, you must subtract the original from the new part and divide it by h with the limit as h approaches 0. And as you simplify, this ends up being this, and you could factor out the h, and it will simplify, and you could end up with this. And this is the point that you could just simply plug in 0 to the h's and end up with this, which is equal to the value they give you. For part C, they ask, okay, for part C, they give you a point, and from there they give you the point -1 to -2, and from there you have to plug in 1 to find the gradient or the slope or the derivative at f prime of x equals f prime of x of 1, which is going to end up having a gradient of -1. And from there, you set the derivative equation to -1 to find the second point that it crosses, or that is also tangent to. And from there, you will get the second point is x equals -1, and you will plug that to the original equation to f of x to find the position, which is 4. So the final coordinate is -1, 4. And in D, in order to find the can you pause this? Okay. So in order to find the section that is decreasing, you must find the change in concavity, which means you have to set the derivative equal to 0 and find the points that it makes to 0. And in order to find the points of that's decreasing, you find a number that is way less than this number, which is the value of derivative that would equal 0. And you figure out whether it's positive. If it's positive, that portion of the equation of the derivative is increased. The portion of graph of f of x will be increasing. And if it's negative, so if I plug in 0 to the derivative, it will be negative, therefore it will be decreasing. So this is going to be the 2 points that will be decreasing. Therefore, P and Q is going to be plus and minus 2/√3. And for E, in order to find the range of values of the gradient of f, that means you have to find the maximum and minimum of the graph of the derivative, which means that you have to take the derivative of the derivative and set that equal to 0, and you'll find the part that it changes concavity. So from here, the derivative equation is 3x squared minus 4. The derivative of that will be 6x. You set it to 0, and you figure out that the part of the value of x that changes concavity, or the point of inflection of f of x, and the point of concavity of the derivative is going to be at x equals 0. So you will plug 0 into the derivative, and you get -4. Therefore, the range of gradients will be the range of gradients will be the values are greater or equal to -4.